Коллеги, я думаю,
Colleagues, I think that we can start. It will be just as interesting presentation about the synthesis of Postgres and Patroni. Viktor Eremchenko will tell us about very interesting cases of this cooperation in Miro company. Thank you. So, can you hear me well? Okay, that's great. We can start now.
Делиться историей о том, как
Today, I would like to share a story about the fail-safe concept, why it was so important, the fail-safe characteristic of databases, and how we brought it to the production phase. A few words about myself. I'm team lead of DevOps in this company. I'm responsible for availability of our server globally. We're responsible for implementing architectural solutions and delivery of software products. Mira is an online platform for visual collaboration of users. We have over 3 million registered users, and every day over 60,000 active users use Mira. One of the main functionalities of is the dashboard. I will also speak about the testing phases, and at testing we had to maintain the simplest work of the users. Our users can collaborate online and they do things online, real time, so we were looking for a solution that would help maintain operation of our users comfortable. We are in Amazon, hosted in Ireland. We have over 150 servers, out of which over 50 are with databases. What do we have in back end? It is a monolith Java application which maintains statuses to ensure collaboration of users. Our application interacts with two databases, Redis and Postgres. In Redis, we can write up to 100 queries per second at peak load. In Postgres, we write about 10,000 transactions per second, but at testing, we can maintain even more. Why was it so important for us to achieve fail-safe mode? Because we're transitioning from Redis and Postgres, and we do it real time without stopping the operation of our application. I will not speak about this. My colleagues wrote a couple of articles on Harbor, and I will provide several links to them in the end. Let's have a look what our architecture looked like when we just moved to Postgres. Here are our application servers directly going to Redis and Postgres. Postgres was made of two nodes with synchronous replication, master-slave replication. It was easy, it looked easy, it worked well. But as we transitioned, in Postgres we had more and more data, and our product was also growing. We had more users, and Postgres was not sufficient. So the challenge was how we would balance the connection to Postgres and store all data if Postgres was not enough. Why was it necessary to balance the connections? Each connect is used through CPU. When you have 1.5 thousand connects, you use a lot of resources to maintain those connects, which is not beneficial. So the first issue was addressed through the Connect Manager. We had pgpool and pgbouncer. We selected pgbouncer. It was working in the transactional mode, and pgpool couldn't work in the transactional mode. So we resolved the Connect Manager issue this way, not to put all data in Postgres and swell it. We decided to make steps. We decided to chart, and we did chart on the application level. Our application knows which chart to go and for which data. This is the arrangement. We have the application servers followed by pgbouncer, which monitors all databases and all shards. Postgres, and each shard has its master-slave in synchronous replication. This arrangement worked for quite some time. How long did it work? Until which moment? Right, until PGBouncer died. We're on Amazon, and instances tend to die in Amazon. Amazon provides capacity, but those capacities may turned off, can be reloaded, which is normal practice. When your data moves to new hardware and things continue to work, Amazon say ensure fail safety through redundancy on your side. We were able to handle this incident, although in this case we received 20 minutes of downtime in our application operation. Our users could not use our service. Not all data necessary for operation were in those Postgreses, and Postgreses worked. Only one point failed. As a fact, after this incident, we did retrospective and developed actions. We ensured fail safety of PGBouncer, and we thought, what if Postgres master fails? We have scripts that do switches, but they should be reloaded manually. We have never tested them, and it takes time, and you cannot always react to things like this. So we wanted to resolve this issue. Fail safety of PGBouncer was simple. We took one more PGBouncer and installed the balancer. We have the network balancer, followed by two PGBouncers, and each PGBouncer monitors the same number of Postgres steps or shards. If one of them fails, all the rest will continue to operate, including the application. Those connects on the PGBouncer which dies, they're reconnected to the other PGBouncer, which was a simple and easy solution, and cheap as well, and did not require too many efforts. Thereafter, we thought how to make our Postgres fail-safe, to ensure comfortable operation, to make us sleep quietly at night. For that, we considered options. Let's have a look at them one by one. Write failover on our own. It's a good solution if you have one Postgres shard. And you can easily do this. Pros, it is easy and simple, easy understanding on how it works. You write the script, you write the code, and you understand how it works. There are no manuals. There are cons. When you switch from master to slave, promoted master to slave, you are left without a replica. And then you need manual actions that would help raise the required replica. And then you should pray to make sure your master is still alive. Sometimes the master did not die, but the scripts thought it did, and then you got two masters, and you do not know which master holds the recent data. Also, when you have a lot of Postgres clusters, you have to monitor scripts. You need a guarantee that they will work. So this solution was not good for us. We considered Rep Manager. Pros, that it can manage Postgres cluster, but this is it. It doesn't have the automatic failover. So this option was more complex than the previous one, so we decided not to do it. No. RDS Amazon. We are on Amazon. Why not use a solution provided by the cloud provider? This would be logical because we use the cloud. We should use it as a cloud, not as a data center. What are the pros? Automatic switching. If master fails, Amazon promotes replica to master, changes DNS name, and everything continues to work. With that, however, there were cons which stopped us, prevented us from going for this option. The main con is price. If you have own software instances, you pay one price. If you use RDS solution, you pay 1.7 times more. This is a minus, but at the same time, we should account for the Postgres service costs. So the other con is RDS does not have fine-tuning of Postgres. You can adjust only what Amazon allows you to adjust. You do not have full access to the server, and we needed it. And on top of that, you do not have access to the instance itself where the database is located. So you cannot tune the instance itself because the way we work with the database is very special. We were looking for some value for TCP/IP Live to be set on host systems to correctly transact. And then we thought, is there anything else? Yes, there is. There is Patroni. Patroni is an open source project from Zavanda. The original code, the source code, is put on GitHub. It has rich documentation, detailed. All commands are described, all configure options are described. So the developers invested a lot of effort in it. Out of the box, it maintains the automatic or supports the automatic failover. Patroni controls the cluster and understands how to switch if something fails, if the master fails, or if other operations are necessary. Another plus is that it is fully written on Python. I will later explain why it is important. It helped us a lot as we went along that path. And it fully controls the Postgres. Patroni fully manages Postgres. So we decided to go for Patroni. It was important not to forget that Patroni would be used on the current servers with data that were in production, and we had to ensure all kinds of cases. So before rolling it out, we decided to test it. Let's remember our architecture, the original architecture. We have the balancer followed by PG bouncers, watching shard Postgres. All PG bouncers control the same number of Postgres shards with synchronous replication. To roll out Patroni, we had to select the distributed configuration storage. Patroni supports DCS, etcd, and at some point we thought we had console cluster, which we had deployed long time before, to keep confidential information on it. So we thought, why not use console? Why just let it waste its time? Let's have a look how we work with console. Patroni cluster contains 2 nodes as a minimum. Also, the terminology changes. In Patroni, master is a leader and all slaves are replicas. And I will use this terminology. I will use the leader and replica words. So it is made of 3 nodes maintaining the same state, same status. And at every moment of time, Patroni sends status to console. So console always has the recent statuses. To connect to console, it was sufficient to check the Patroni documentation, which says, so define the endpoint, and there is also an optional parameter which is scheme, which does not influence anything. But as secure people, we use HTTPS. We thought our config should look like this. But it turned out it was the first stumbling stone. It didn't work. As we searched for some answer to the error generated by Patroni, we Googled it, and Google suggested replace Patroni with Patron. Maybe you're looking for munition. No, this is not, because Patron is munition in Russian. So we checked the code responsible for connection to console and found that it was all very simple. Host parameter does not partition to HTTP or HTTPS, and schema parameter is necessary if you use HTTPS. It wasn't quite obvious in the manual, but this config helped us a lot, and everything worked. Further down the road, one of the issues was we had to make PGBouncer and Patroni friends. They were separate instances, and as cluster Patroni switches, PGBouncers understand which one of the clusters is the leader. And template cluster helped us here. The console template every second, or even faster or longer, depending on the settings, request the console to see whether the status has changed. If changed, it picks the template and updates it at PGBouncer or reloads PGBouncer. So as you replace the cluster leader, you change the configure, reload, and all connects to that shard switch to a new master. All old connects, they die. After we do this, we get the following arrangement. Network bouncer for the application server. We have two PG bouncers looking for clusters of Postgres. Postgres is made of two nodes, leader and replica. Each of those nodes writes to the console cluster the status of its cluster, and console template monitors the status, seeing whether the leader has changed or not. After we did this solution, we decided to test it. So we created a sticker and we moved it somewhere. So we made this small test on a test bench. We created a sticker and simulated the user operation to see what happened. So we killed the Patroni cluster leader. It is easy to kill it by turning off the instance. So we move the sticker, and the sticker moves back. So the transaction is rebounced as we switch to the cluster. So the users see that something is wrong. At the same time, it doesn't receive any changes and continues to work. It continues for 10 to 20 seconds, and after that, he can continue working. So our application sustained this change, and the operation of the users was not affected. It was very good for us, which helped us move forward. And we decided to roll it out. But before rolling out, we still had some issues. How will it work at peak loads? We tested it in the test environment with one user. What if we have 30,000 users working simultaneously at the same time? We don't know what will happen and how to roll it out in production safely and reliably, because we have 10 steps of Postgres. There are data on how to roll out Patroni clusters to ensure the integrity of the data, to make it fast and seamless. So for that, we have staging platforms identical to production. It may have fewer steps of Postgres. With them, or on them, we perform load testing. So we decided to test the rollout of Patroni on them to see how we can address different issues if they arise. Another stumbling stone was when you have Postgres cluster shards, they're called main, the same name, because they have no idea there's another Postgres cluster next by. So when you keep cluster status in console, the cluster names should be different, otherwise they will think they belong to one cluster, and there may be other issues. For ideal logger may be different and they cannot be launched. So to address this, to change the cluster name, we had to change the cluster name and reload PostgreSQL, and Postgres will continue working, so we did it. The next stumbling block was the launch. When you have the old master and old slave, and they have similar data or identical data with synchronous replication. So we roll out Patroni and launch it. But Patroni doesn't know which one was master and which was slave. That's why they are launched as leaders concurrently. So the resolution was simple. But don't tell anyone that I told you to do this. Delete the data directory, and Patroni will think it's a new replica, do base backup, catch up with the status, and start working. This is good for the test environment. Better raise the clean instance and connect it, and keep yours just in case. This is very serious, because it is very easy to make a mistake, to confuse the windows. It is easy to confuse IPs or tags and delete the production data.
And another problem we're faced with is that due to unknown reason, Patroni wasn't launched. We have a cluster, we launch it, but Patroni fails and doesn't show us any error. And on the web, in GitHub, you can find recommendation from the developer. It states, stop Patroni, launch Postgres, check if there is an error in Postgres or not. If it is present, you can fix it, and if no, you can stop Postgres and launch Patroni. This case is possible in two cases. The first one, there is an error in Postgres, and Patroni doesn't show this error. And this error can be visible in the log of Postgres when you launch Postgres. And the second case is then you start instance from Patroni tries to be launched, but it cannot be launched because it needs temporary directory to preserve bit file. But it is created by Postgres only. Patroni cannot create it itself. And we actually settled this problem. We wrote a service that creates directory before Patroni is launched. Of course, this is not a beautiful solution. However, we didn't have another option. And after we tried it during the test, we decided to test it with a load, and actually we checked the scenario that will deploy Patroni cluster on production. We selected our board, we took a sticker, we specified an average daily load that is about 15,000 users, and we switched off the leader through Amazon console. We moved the sticker goes back, and in about 20 or 30 seconds everything recovers and it continues working. The only issue that was different from the first test is that we received quite a lot of errors in our application that stated that Postgres was not available at this point. It meant that the transaction was brought back, but 30 seconds after it, these errors were not shown and the application continued its operation. So the solution is ready for production. Before deploying on prod, we needed to deploy console template on PGBrowse and launch it. We needed to change the names of clusters, and we also needed to launch Patroni cluster instead of Postgres. It's important to mention that when you do config of Patroni, by default, there is a section with initdb. If you deploy it on ready base, you can eliminate this session. The first point is we managed to fulfill it without stopping the application, because it allows us to deploy the console to conduct some actions, and we deployed console template without stopping our service. For this purpose, we used the script that was tested in the environment for load tests. The deployment of Patroni cluster was not as simple as we thought before. And the both scenario included several stages of testing. To make sure that everything is fine, without switching off our application, we tried deploying it on one unloaded shard in one time with the data of our account only, so it contained only the data of our company. And for 3 minutes, it was not available for our account. So the deployment actually was a bit longer than we planned. And we asked ourselves, how will we do it for other users? Because it's not really good to stop the operation of the service for 3 minutes. And it's better not to do it unless we warn the users. And actually, according to our policy, once a quarter we have a window for maintenance. That is 1 hour, once per 3 months, when we conduct the necessary operations with the databases. We install critical updates, various patches, we add something, we migrate on them, we conduct some works. And 1 week was left till this window, and we decided to prepare our scheme and add 2 nodes to every shard of Postgres. One slave would contain the latest data. It will be a backup slave, so that if everything goes wrong, it will be possible to roll back to the previous schema. And one Postgres was a new one without any data. It already contained Patroni, and it was to become a replica in the new cluster. So, in the time of deployment of Patroni, we stopped our service, fulfilled our scenario, and everything worked out. We deployed Patroni on all Postgres shards. All shards started operating. We waited till replicas get base backup till they reach the latest state and become ready for switching in active mode. After that, we launched the service, and it turned out that everything worked. So the users could use our product once again. Well, there were some issues. On some shards, something was failed, but taking into account that we had more than 10 of them, and when one shard fails, this is a minimum problem that was fixed very fast. After that, we didn't stop. We decided to improve this scheme a little bit. So, we would add additional replica to every Patroni shard, so that if the leader dies, the switching will work out, but one leader will remain without replicas. And what will happen if it dies as well? In that case, we remained without Postgres. That's why all clusters of Patroni have 3 nodes. One of them is the leader, and 2 of them are replicas. Everything is written in console, and PG Bouncer with console template can get the state of the cluster. If the leader fails, then inside Patroni, a new leader is selected, and it is switched on this leader, and PG Bouncer is switched at once. It really works. For example, over the last half a year, it saved us about 5 times, because once a month, one node dies, and Postgres is switched. Sometimes it happens unexpectedly, so you couldn't even imagine that. Sometimes it happens at night, and the person on duty can sleep. They do not have to respond to it, because if they come in the morning and return the previous leader to the cluster will operate quite normally because it has another replica. So, what are our feelings? What are our opinions regarding Patroni? It's very convenient in terms of updating Postgres. If you need to use a new parameter of config, you can do it on any node of Patroni cluster, and this config will be applied for all the nodes of cluster. And if restarting is necessary for the use of parameters, Patroni will show it to you with an asterisk. It will tell you that these changes will be applied after restarting, and it is really convenient to work with Patroni API. API. And recently we started applying all the changes through API so that it will be more convenient and faster. But it's important to remember that it is necessary after the changes were applied, it is necessary to add new parameters to config, because if you restart some node, probably after restarting it will include some previous changes, because Patroni stores everything in console parameters, but when it starts, it takes them from the file on the disk. And it is also important to take into account the following. When you want to restart Patroni cluster, this is done by one command as well, that is restart CO cluster command. And at that time, probably it's better to do a checkpoint in advance. In that case, restarting would take very little time, so it wouldn't last several minutes. Automatic failover works as well, and it works quite well. So at the time of switch, we can get a pool of errors that is normal, but it takes about 30 seconds on the average. So the users that had data on this chart have their transactions rolled back, but we're satisfied with it. So we cannot actually achieve less than a second, and several seconds, several dozens of seconds, that is normal for us. That is not about minutes or dozens of minutes, and this is not a problem actually. And there is another bonus of Patroni. You can update Postgres without stopping the application, but you should do it within one version. So you can follow Postgres documents. You can update replicas from 11.4 to 11.5, for example, and after that you do a switch over. After that, you should update the previous leader, add it into the cluster, and it will work, and the application will not stop. So in the past, we needed to do it in maintenance, but now we do not do it in maintenance. We can service Postgres within any time, and there is no need for us to have a separate window for Postgres. Indeed, we have some problems related to Patroni. When we deployed the solution and started using console, we received very high load on CPU, and all of it was on CPU on console, so that was about 80 to 90%, while we didn't have a large load on the servers. And it turned out that it was quite simple. Our console cluster was a bit forgotten and no one updated it. And as there had been no updates during a year, it turned out that there were various leakages on CPU related to console templates. So, console update helped us resolve this problem, but when we started updating console, we received another problem related to Patroni. When you update console, you can change the leader of console cluster to any node. It happens easily. Patroni understands it, and it works. If you eliminate a node from a cluster and Patroni switch to it, it will be switched to other nodes of the cluster, so it works. But when you need to eliminate the last node from the cluster, this is the last leader, so everything was updated and it is operating on the old version. When you do the switch of this leader and you do console leave, there is a brief lag in the console, just several seconds. This is a cluster freak, and Patroni doesn't respond well to it. It shows an error. It states that it cannot get the state of cluster from console, and it restarts all the nodes. So, at one point of time, 15 steps of Postgres were restarted, so 45 instances of Postgres were restarted. We have not resolved this problem yet. We know about it. We have various options for resolving it, and after it, at some point, when all nodes of the cluster are restarted, we don't know what node would be a leader. It was quite an unexpected behavior for us, but we have console, tempoid, and PG bouncer, so we can work with it normally. That's it. Thank you. As I said, there are links to our articles in Harbor. You can read them. And if you have some questions, you can ask me on Facebook. Thanks a lot. I think that the issue of all nodes restart can be resolved by using etcd. Actually, we were faced with it and we had to migrate to ECD from console. Yes, we're considering this issue as well. Hello. Yeah, Victor, thank you. And can you return to the final schema? Okay. So the question is, what is this network balancer? Is this crash point? And am I right that when the leader crashed, it switched to the second replica, but you have to return the leader manually? Am I right? Yes, we return the leader manually. We do not do it automatically. If the node was restarted due to Amazon, if it reconnected by itself, then Patroni will be switched automatically, and probably it will get into the cluster if we have enough segments of the full log and they will not delete it. These can be regulated by config parameter. If the load of segments is very high and the segments are not sufficient, it will not connect cluster and we need to manually add it to the cluster. So we need to follow the scheme on eliminating data so that base backup would be accumulated and after that lag will be accumulated. Regarding network balancer, this is a solution from Amazon. Amazon guarantees fault tolerance because there are several of them in various zones of availability. So if one of them dies, everything goes through the second one. And in this case, Amazon undertakes this responsibility for providing the service. Hello. I have the following question. Can you tell us about the way you back up data of your cluster? For example, you have a bomber that uses replication that is aimed at master with a specific timeline. And when the switch happens, how do you transfer to backup? For backups, we use WAL-G. I mean that from the leader, WAL-G always sends WAL logs to S-stream, and once per 4 hours, base backup from one replica is done. And I have another question regarding the response of cluster. There are settings TTL and loopoid. And can you say a few words about them? What did you select so that all these lags and all these accidental issues would not react? When we tried to resolve our problem regarding Patroni restart, when console was not available, we actually talked through GitHub issues. We talked with the developers of Zalanda and they recommended us to make TTL minimum 8, we do not have less, and we used this value. Loop wait was 2 seconds and that's okay for us. Okay, another question. So you said that your console has a specific service that is actually divided from Patroni and console and Postgres. And the console itself, I actually use DCD and console, and both of them are very sensitive to the disks where they are located. Do you have any information about the hardware that was used for console, for the disks? Well, regarding the disk, we never had any issues. Regarding console, there is the issue of CPU. The more frequently it is addressed, the more frequently it asks for CPU, and in this case we used scale up. So when we deployed console cluster, there were its own issues, its own difficulties and downtimes, because we actually switched all the website to the work through WAL, through console, and console WAL are on the similar nodes. That's not appropriate actually, we should divide them. And in this case we used the instances that are similar in terms of CPU and memory, that is M generation, M5, XWash. I mean about 16 gigabyte of operating of short-term memory for console and for CPU for console only, yes. Thanks Thanks a lot for your presentation. We are in the beginning of this way, so your experience is very useful for us. You are in one availability zone or in different availability zones. We are in one availability zone now. Indeed, we plan to increase our fault tolerance through replicas in other availability zones, but we don't know how our application will work with it because of the increase of latency, and price is important as well, right? I think that within one region the price is similar. I mean that if new availability zones are present, if the replica is in a different zone, it will cost you more money because of the traffic, yes. Thank you. And was it possible to avoid the fall of your rates when console was updated? If Patroni nodes had a local console agent, it would see other servers as well, and it would not react to Patroni that much. So Patroni wouldn't actually react that dramatically to these fault that lasted several seconds. We thought so as well. We actually managed to repeat this problem in test environment, and we thought about the options that would help us fix it. And agent console was an option that could fix this problem for us, but it turned out that it didn't help. So in our case, we received a similar error, a similar problem, because console agent was slow as well. And this cluster is continuously changing, so it needs to get the latest changes from the main cluster of console. It cannot actually maintain this state. There is no sense of caching it because it changes every second. Okay, so it didn't help. Well, probably your loads are different. Well, I have a second question. You said that two nodes were launched at the same time as a leader. How can they be leaders if actually console states who the leader is? Only one of them can be the leader. Look here, the second node was not launched. It failed with an error, but actually this error stated that this cluster has a leader as well, so we tried to connect this cluster as a leader, and the leader will be the node that actually wrote to cluster console the first one. And if you launch the second node in a second and it has the similar cluster name, it will not be launched because the log ID will be different. It will say that I'm trying to be launched as a leader, but I cannot do that. So Patroni will actually try to reach restart. And is it possible to use reunite through Patroni CTL? Is it necessary to eliminate the folder? Probably. Probably it's possible, but actually we did not eliminate the folder. When we deployed it on prod, we connected a replica without data. Thanks.
Вопрос.
One more question about configuration. What is the minimal configuration if you have one leader and two replicas? So what about the servers? How many servers would you have? I see 3 Postgres servers, PG Bouncer, 2 separate ones, that's right, and 1 sub-console. Yes, we have 3 console nodes. Can we discuss this offline? We have time for 2 more questions, 1 minute each, and then we'll have a coffee break for 30 minutes, and you will be able to discuss Postgres settings during the break. My question is about HTTPS should be indicated in the scheme, and about the console. Thanks to you, there is an issue on GitHub. And the second question, the question itself, you said that you could update Postgres between minor versions without stopping the cluster. Question. What about the replication wall? It cannot operate across the versions or between the version, but the manual says minor updates can be performed and everything operates well. Well, as far as the issue on the GitHub is concerned, yes, we put it, but it was closed. It was shut down before the new year. And the second question. I'm on your right-hand side. Thank you for your report about the console update. Patroni cluster on pause in the so-called maintenance mode doesn't it resolve the problem? I'd rather say yes, it could help. We haven't tried it. Because in this mode, it doesn't react to any changes, so we can do whatever we want around it. Thank you for this point. We'll try it. And a small comment. In this case, Patroni is prohibited from making any actions with respect to the Postgres. Fortunately or unfortunately, it will not change anything. So to install Patroni in maintenance mode, your application should operate. We want to update it as any server without stopping the main application. And in this very case, it's not applicable because we want to update the console as well. You have short maintenance windows, but I guess it disciplines you to do everything in an hour, once every 3 months. Thank you.